If you like this video, make sure to subscribe to our channel and hit the notification bell icon to get the latest updates.
Yeah, can all of you see the screen?
Yeah.
Yeah, we can see.
Okay. So we'll start with this, and if others have to join, they can join in between, because this is going to be a very introductory session wherein we are going to discuss more just about like what data science is and what is all this hype about data science, and why, as you told, that all of you have some experience of more than 10 to 15 years, so you are aware of it. So we're just going to go through the basics of it, what it is, and why we are basically so much demand of data and everything. So we're just going to go ahead with that. Okay. Okay. So I'll just briefly introduce myself. I have myself Austin, and I have around 6+ years experience into data science and machine learning, whole data science and machine learning. Okay. And I have also worked in various verticals, like it has been into BFS sector, then retail, foods and beverage sector, academics, and I also worked in some of the non-profit sector in solving their, business problems, mainly with the machine learning techniques and data science and database solutions. That's what I have provided. Along with that, the expertise that I have as far as tools are concerned is Python, R, SAS. I started with SAS when I joined in, but then I slowly migrated to Python, R, and now I'm more towards deep learning and AI aspects of it. So that is where my most of my experience has been till now. And as far as this training experience is concerned, I have taken 25, more than 25 sessions actually. Not sessions, actually, more than 25 batches. So basically, when I started, I started learning and I started teaching. It has been around same amount of time, like around 5 years, for more than 4.5 to 5 years, I've been teaching and taken multiple batches across. I have also given some corporate lectures in different companies and so on and so forth. And I also, I mean, as far as teaching is concerned, I have been doing it for quite some time. Right from my school days, I started teaching some, non-profit kids, the underprivileged kids, and later on, I also took on to some yoga and meditation, which I just taking for as a hobby. So basically, this experience has been for quite some time now. And this the relevant training experience, if you have to ask, this machine learning and data science is for more than around 5 years training into these areas. I have worked on, and I have also done projects individually when I started. Now I am leading teams also into various teams, like which has been from 3 to 10 people and so on and so forth. So in developing various machine learning and software-based solutions in the analytics space. So we have deployed solutions for more than 3 million POS machines across the country, and multiple for the top merchants in the retail and electronics department. We have sort of created solutions for them to to acquire new customers and retain the customers, and all of them having database solutions. So this is pretty much about me from the project side. And as I've told you that mostly I have worked with R, SAS, Python, and because I'm more going in towards artificial intelligence, so Python is becoming much more relevant. And these are the some of the areas where I have been working: deep learning, natural language processing. Various skills that is required in all those areas are like XGBoost and all this reinforcement learning, deep learning, and so on and so forth. So those things have been my prime areas of work. So as we move forward, if you have any questions, you can ask me related to that, and I'll share my experience also in working in these different kind of sectors. That how, I mean, they have helped shape my experience, and I have learned through them. So as we move forward, all the whatever I'm going to talk mostly will be from the experience part of it. Okay, so now about this agenda of this particular session, as I told you, this is just going to be introductory session, and what we are going to cover as part of this, and so on and so forth. And most of you, why I wanted to have your understanding is who you guys are, is basically I wanted to see that how much experience do you have, and accordingly I'll just take the session forward. I have a slide. but mostly I'll keep it interactive so that it doesn't get very theoretical and and so on and so forth. So we'll see why data science is required, and what are the various things that we are going to cover as part of this data science master program, and some generic information like what are the applications and of data science, in which areas it can be used, how it can be used, and later towards the session we'll have the question answer session that we'll go ahead with. Any questions till now?
No.
Okay. Okay, so now, right, coronavirus. Why I basically wanted to get in touch with this particular aspect of here is, first thing is why data science? Why do we need data science, right? So one thing is obviously from our perspective it's needed, but data science can in general solve a lot of problems. And coronavirus being very a catchy subject, all of us have been affected by it. So I just wanted to show you some of the things that are being done by the data scientists in this space of researching for various vaccines, providing different kind of solutions in fighting COVID-19. So this is from World Health Organization, and this is the data. Just I'm trying to show that how all these things, like all this visualization that we're trying to see here, is coming from World Health Organization, which is taking care of that how it is increasing day by day, and what is happening in this, right? So the total number of cases has gone up to 6.7 million. 395,000 people have died due to coronavirus. So I'll show you this. As I told you, we'll keep it interactive so that it doesn't become a lot boring or whatever. So this is from here. This is taken, right? So now you see one thing. This is one aspect of it, right? So so the data is everywhere. Now the data is coming from everywhere. All the countries are providing the data, and this dashboard has been created. So dashboard is more about visualization. So visualization is also a part of data science, wherein we try to give better KPIs so that we have the understanding of data in better sense. So this is what it is trying to give. Okay? This is more from the geoanalytics point of view, from the visualization point of view, that how the things are moving in this space, what are the total number of cases we can. So this thing has been made at the back end. Some of you might have heard of Tableau. So on the back end, they have used this Tableau along with the John Hopkins University, and they try to create these dashboards to have the better understanding of it. So this is also part of data science in general, right? So we can go down and we can see that how these things are happening across Americas and everything. So just to give you a glimpse of what all is happening, and all these things are being done by data science itself. So in different departments, different kind of researchers are doing it in different ways. So this is one application of it. Harvard is doing their own work. Harvard University is doing their own work to fight, COVID-19 situations, and they are doing their work along with this. So this is one part of it. Now, so why data science? The point is, it is able to solve a lot of problems. A problem like this, a pandemic like this, data scientists are proving that they have a very useful role to play in solving the problems related to data science. We'll see some of the things in the slide, that how they are basically. So one thing, some of you, as you are in Bangalore, and this Arogya Setu web, that is basically being used by Indian government. So what they are doing is they are using the Bluetooth and basically the geolocation of the people, and trying to map whether these people are in the area where corona outbreak has happened. So basically, using this geoanalytics, they are trying to come up to some kind of inference whether how you should behave, whether you should step out. So this kind of information is being basically given by Arogya Setu. So on the back end of it, it is all data science is playing a very pivotal role in keeping people safe, or trying to at least keep people safe through these applications. And this is not just about India. Many other countries are using these kind of technologies to help people in whatever way they can. Okay, so some of them, as I told you, some of them are using like Oxford, John Hopkins are using, and their research departments are basically coming out with different kind of hot spots, like which are the areas mostly affected using the geo analytics and geolocations. They are trying to come up with certain things. So this is one aspect, and like this, there are many other ways in which they are basically using data scientists. So this is from various different kind of newspapers and all those papers, like South Korea is doing something. Singapore is doing the contact tracing in better way. So all these things at the back end is basically being conducted by data scientists. So why I'm trying to, the point I'm trying to bring home with all these things is that data science is being used in very, very dramatic ways in all these areas, which is basically affecting people's lives. So this is where, and this is a very critical phenomenon. That's why I just wanted to give you a glimpse at where we are with the data science. So as you can see, data science use machine to find possible cures faster. So many things are basically being reported that where, how, and where they are basically being used. Now, so what is data? This glimpse of what happens with the, what are the greatest applications that are being used with data science. Now, what is data science? So science in general is basically about coming up with some kind of objective, objective inference. By exploring certain things, we come with some kind of objective inference. So this data science is about analyzing past data, and with the analysis of the past data, we infer something. Like let's say that we are examining data of a bank. Now, in a day, millions of transactions are happening in a bank. With that information, we are trying to figure out, let's say for one example, just for one example, whether the fraud has happened or not. So millions of transactions are happening. Now, based on that data, by analyzing that data, we are trying to come up with certain kind of inference, whether the fraud, what is the possibility? One thing is whether the fraud has happened, or what is the possibility of the fraud being happening. So basically, in a way, data science is about understanding the current data, understanding the pattern of the current data. Can we find some pattern and infer something about the future? So this requires different kind of skills. One thing is mathematical and statistical skills that you will need, some programming skills that will be needed, and obviously experience in the domain, like substantial expertise. So the domain expertise also becomes very relevant in these cases, because that gives in a way some kind of intuition, some kind of experience, which basically goes along with the prediction that we're trying to make about any situation, like whether it is going to be a fraud kind of situation. So all these things, mathematics part of it, computer skills, mathematics and statistics parts of it, computer skills, and experience, all these things are part of data science. Data science in a way becomes very holistic subject that way. Okay, so this is like, theoretically we can talk about it in many ways. A person who is like, these are the things which have been written in different different journals or manuals. Person who is better at statistics than any software engineer, but better than software. So it is not just about being an expert in one particular area. It is more of a jack of all trade kind of situation, that you may have some expertise in something, but then you need to have a combination of all different aspects that is that is required to solve a problem, and the core of it is data. So we are using to we'll be using, as I told you, it is going to be mathematics, very high level of mathematics and statistics could be used. Then machine learning algorithms could be used, and the language such as Python or R can be used to solve these problems. And along with that, we can use some visualization tools like Tableau or ClickView or Power BI or any other visualization tool, as we're seeing in the case of COVID-19 tracker by who, that they have used Tableau at the backend. So that is a data visualization that is basically happening at the backend. So these are all parts of data science. Now, this one thing I liked about this Harvard, this came in like from Harvard Business Review. What they said is that analytics has been there because data has been there for all the time. So descriptive analytics is mostly about that whatever data we have, we are just trying to analyze that and come to that what that data is saying. Then based on that, we are trying to make some kind of prediction. Like let's say that we have a report of 5,000 people who have left the bank. I mean, who have attracted the bank. And then based on that report, we are trying to figure out, we are trying to understand the data, and we are trying to figure out who are the potential customer who can leave the bank in next couple of months. So that is predictive. But more than predictive, what has become important is the prescriptive analytics. Prescriptive analytics means we are, because mathematically we can come to some point, but then whether that insight is being used and in solving the problem in the business in a holistic way. That is about the prescriptive analytics part of it. So it has been always been there, but now as they are saying in the Harvard Business Review, that it is more about solving problems. So where prescriptive analytics is becoming much more important than anything else. Prescriptive analytics means that insight-driven solutions. That is what it means in very layman's term. Okay, so but then based on my experience, if you ask me how do I define data science? So data science, I define data science more from the art and science perspective, because based on my experience, this is how it has been. Because science is one thing where we are, creating two kind of situations here. One is machine learning, and another thing is machine learning programming, and another thing is mathematics and statistics. So this is more from the science part of it. But the art part comes because the experience of the business, or the understanding the situation itself, gauging the situation and trying to solve problem based on that is more of an art rather than a science. Because a statistician may have some kind of number based insights, but that number based insight may not go intuitively along with the business solution. That is why the understanding of the business, the understanding of the domain becomes very, very important in solving the problems which are related to the data science. Wherein, as all of you are most of you are very experienced in your businesses and in the various verticals which you have worked in, be it in HR, be it in any other verticals. So that experience is going to play a pivotal role in whatever you are trying to do. Along with, and when you couple this with the tools and techniques which you can learn as part of this course, that is going to provide a highly sophisticated solutions to solve various business problems. So that is why it becomes a combination of art and science. Any questions till now? Any questions?
No, Austin.
Okay. Okay, so now these things definitely you would have heard, because all of you are experienced. This started to happen after 2010. That suddenly it was all became a big thing. That people started to say data is new oil. Harvard started to quote it as the 60th job of the century, and so on and so forth. Many lofty statements started to be made. Now the whole question was, why suddenly there was such a shift? Like, why suddenly this became such a such a hype after a point in time, after 2010, I would say 2009, 10, 11, it started to become such a big hype. So what drove this thing, right? We need to understand that also, that suddenly why this in this particular decade, this data science and machine learning and all these things became such a big hype. So now let's have a look at this. Any guesses what is this? Anyone wants to guess what is this? Okay, so I'll tell you what this is. Basically, this is the memory device which was created by IBM in 1950s, which is 5 MB chip. Basically, now it's not a chip; it's a hard drive kind of thing, big drive. So this is 5 MB. So what happens is, to carry this 5 MB thing, they needed an aeroplane. This is what it was at that point in time, right? It was 1950s. Later on, now we have something like this, SanDisk or maybe SanDisk, this chip card, which is just maybe a tip of fingertip, and 64 GB is basically being in this. And now this is something else, that wherein they are trying to fit in the chips inside the mind itself. All this kind of research is happening. So basically the point I'm trying to drive home with this, all these things is, one thing is the data storage itself has become the technology has developed to a point where storing data has become very, very efficient. And this is becoming continuously efficient. So this is one of the factors, as I told you, why all this sudden excitement happened, because we have technologies now which is helping us store a lot of information in a very, very small kind of devices. So this is one part of the game, that suddenly this so much thing started to happen about data sets, because a lot of data now can be collected from various different kind of sources. As I told you, this is not a new tool. As I trying to tell you that in 1950s, that a small that 5 MB drive was created, which was to be carried on an aeroplane. Now, in this case, if you see that all these people in the space of specifically in the space of statistics, the researches started to happen in 1940s, 1950s, 1960s, and so on and so forth. So most of the things that we are going to even learn as part of all this are going to come from all the discoveries or all the inventions which were made before 1990 itself. Most of them were made before 1990 or 1980. But the only problem with all those algorithms were that they could not be implemented on the large scale. Their one requirement itself was that large scale data should be there. Now, large scale data was not possible because of the technological handicaps at that point in time. Now it has come up. So we are going to, so all these things have become much more easier. Now, all those algorithms which were developed in later part of 1900s became very useful in the last one decade. So this is how all this progression has happened in all data science space. So you know all these things, velocity, variety, veracity. So all these things are there. Which data has come in different kind of volumes, all different kind of. I mean, it is coming from different kind of sources, and speed at which it's coming. Like let's say that in a day, kind of zettabytes of data are being captured from different sources, be it from sensor sources, be it from social media, be it from different kind of other mediums. Even in banks, they are storing data in terabytes now. It is on a daily basis. So different kind of and different levels of data. There's structured data, unstructured data, text images, video. Video data, all kinds of data, sensor data, various different kind of data are available. They're coming in different forms, and they're coming to us, and we are able to store them with all the new technologies that we have in our hands. So now the question is, can we, storing data is one aspect of it. Can we do something about this data which is coming at such a speed and in such a volume? So that is where all this machine learning and even the later technologies like deep learning, artificial neural network, and further, technological improvement which is happening is more about making sense of the data from at which they're coming. So this is about, and this is what big data is basically about. And with the invention of big data, all this technological and coupled with the technological advancement in computational power, we are able to leverage the data and use it for our benefit. So that is what is happening. And there are different kind of data, as I told you, archive data is there, internal documents from different kind of banks, are there multimedia files, digital files, pictures, videos, text, all kind of sensor data, social media data, machine log data. So various data sources are basically adding to all these things that is happening in creating the data repository, which is basically being used. With all the online clicks, so much internet activities are happening. Internet of Things is another, game changer in all these things, where a lot of devices, electronic devices, are basically being connected through internet, and they are producing their own set of data. Scientific computing in health sector, in different kind of discovery. I mean, various research areas are there in which data is being computed. And generally, even with people, they're using YouTube, Facebook, different kind of Instagram, and all these, and there are various different kind of devices, also tablets, mobile, laptops. So all these things are there, and they are basically adding up to the big data source. So this is just more towards that what is there. Some of the, some of the data are valuable, which are useful. Some of them are not useful. Volume is there, where it is a large chunk or a small chunk, different kind of records. So this is more about, this is just about, as I was telling you, what is there, like transaction data could be there. Some of and there are some problems that are associated with the databases. This is more from the database perspective. Just that there'll be many, error kind of thing, and the data may not be regular. So those kind of things are there with the data. So that is just aspect of data, and data cleaning all needs to be done. That is also part of data science itself, where you clean the data because it's coming from all the different kind of sources. So they are not structured. So we need to have a proper kind of format to put them into machine learning algorithms so that they can give us some kind of an inference and predictive power to all that data. So this is all thing that was basically that we have talked about technological advancement in the space of technological advancement driven by various programming languages like Python, R. So they have added to that, and this is one thing that happened in 1965. Gordon Moore was a scientist. He basically predicted this is how the computing power is going to increase. And this is what we have seen. So this computing power is going to increase more further, and we are going to have more data on our hands in very low cost, and high volume data is going to be available. So this is more about that how this data is basically getting generated. So this is just from the Moore's law. Okay, so now any questions till now? Because there are different kind of people, so just I want to be, and most of you are experienced, so I'm just trying to give a bit of glimpse at what it is and what is not. I'm not trying to get into too many details around it. But any questions? Okay, so we'll just quickly go through some of the applications which are basically, some of the applications of machine learning. And so I just trying to make it, because I was not very sure about what kind of participants were going to chip in. So because most of you are experienced, so I'm not going to, because most of you would have some kind of understanding of what data science is. So I'll just take you through the course structure itself, and later on we'll go towards that what applications of data science could be and could not be. But more than that, I'll just take you simply through what is the structure of the program that we are having in this course. So this is what we are basically offering here, right? So this is a master data science program, and we'll be starting with very basics, like even if you don't, but most of you are experienced, and some of you would have some experience with some programming languages also. But we are going to start from very basic here. We'll start with what is data science, how do I basically, what are the various tools, and the tools that we are going to primarily use is Python in our during our course. We'll also touch base upon R, because R is also required in some of the cases, and some of the companies internally have requirement of R tool itself. So we'll also look through R, but mostly, as I told you, because Python is picking up very fast. So we'll mostly delve into Python tool itself in this particular course, and we'll see that as with all the other languages, what are the various data types, with very simple things. Everything from the basic, we are going to cover both the tools, R and Python. Then apart from that, we are going to cover advanced and basic statistics. So mostly all of us would have some familiarity with the statistics right from our high schools and so on. So we are going to cover some important topics around it, which is like hypothesis testing, some of the tests like t-test, g-test, f-test, ANOVA, chi-square, those kind of things, which is more aligned towards machine learning thing, because they will be required to understand the further algorithms which are going to cover as part of this topic. Some part of SQL also we are going to cover, just basics of it, not mostly, like just to see that because in many cases SQL is required, because when you are handling the data, SQL will do it. So we'll go through the very basics of SQL also, and then we'll come to Python. In Python, we are going to start it right from the data extraction, data manipulation, whatever we do in all other tools like data manipulation tools, be it SQL or so on. So we are going to start it right from there, and then we'll use the learnings from that to build on various machine learning models. So machine learning models means what are the models which are basically help us solve problems. I'll show you some of the examples at what kind of problems we can solve using machine learning. But and for that purpose, we'll be using Python. So now in machine learning, it could be like various different kind of algorithms are there. So that is the crux of machine learning, the algorithm section, which is like which could be regression, which could be classification, which could be reinforcement learning, association rules, clustering. Uh, some aspects of maybe text mining and your natural language processing. Some very lightly we'll touch upon deep learning also, which is becoming very, very famous nowadays to solve very big problems. So these are the things we are going to cover as part of machine learning and data science course here. As you can see, all these things, supervised learning. And supervised learning is basically where you have some kind of dependent variable where you're trying to predict something. Unsupervised learning like clustering. Recommended systems, because recommendation engines are being used in solving very different problems. We'll see some examples of that also. And neuro linguistic programming is more towards, just to understand some of the deep learning concepts we are going to. We'll just slightly touch upon it, but then we'll have a look at deep learning as well. Some part of Tableau we'll look at for visualization perspective, but we are not going to cover it deeply. Like as I told you, mostly we are going to focus on Python, because Python is going to solve most of the problems which we face as part of for solving analytics kind of problems. But Tableau and all these things are useful for visualization. So we'll mildly touch upon that as well. And then later towards it, we'll do some capstone projects, like which will be from a retail sector, which will be from uh, which will kind of predicting the churn or predicting the whether someone will leave the bank. These kind of problems we are going to solve. Sentiment analysis, in which we are going to use text mining and natural language processing as part of text mining. So this is what is going to be primarily the content. Some of you are asking about the content thing, that what is the content of the course. So this is how it is going to and this is going to take something around probably from 110 to 140 50 hours, depending upon how the class goes, how many questions are coming up, and so on and so forth. So it's roughly around, let's say, 120 to 130 hours it can take to complete the whole master data science course. Any questions here? Because I think many of you would be more interested towards this. So any questions if anyone wants to ask?
Austin Shishir here. So I have a few questions.
Yeah.
So first I want to understand how is the class distributed in terms of hands-on versus the theory part?
So most that's what I told you. This class is going to be for around, I mean, it could be from 120 to 140 to even 160 hours. As you can see, it's written 160 hours. It is maximum usually. But the way it is that we'll be delving into the theory, and mostly the way I teach personally is solving the problem itself. We'll take up a problem, just have a slight theory of the subject, that how basically Python works, or what is the machine learning algorithm that we are learning, and how we can use that to solve a problem. So it is going to be a blend of both the things, that whatever part of theoretical aspect that needs to be covered, we'll cover that, but we use that to solve a case study. That is how it is going to be.
Okay. And when you say 160 hours or 140 hours, so how many weeks it will turn out? What will be the schedule for the classes, and how long will be the classes?
So this, I think, Harish and team will be able to guide you upon this, that how they're going to basically separate these classes. So as I told you, the class will be covered. Like if you talk about the subjects or topics that we are trying to cover, it is going to be covered in 100 hours. Okay, but then sometimes people have different kind of projects in which they come up and have their problems. So we try to solve those things. So in that fashion, it goes to us 20, 30 more hours, and that's how it becomes. Otherwise, in 100 hours, we complete whatever is covered, whatever is mentioned in the subject, we cover it in 100 hours. That's how it becomes. So it's kind of little flexible that way.
No, so I'm just trying to still understand in terms of weeks, how many weeks this course is going to be will take to get completed.
So this is going to be in, I think Harish should be able to shed light on this. Are you there, Harish? Okay, I think he's left. So basically, see that a couple of ways in which this program is structured. One thing is weekdays program and there is a weekend program. Okay, on the weekend, like Saturday, Sunday, we have 3 hours classes. Saturday and Sunday, so basically 6 hours. So if you divide it by that, then it becomes almost 16 to 17 weeks. So around 4 months. That is what is generally if you're taking up this weekend program. And if you're taking weekdays program, which is like 2 hours for 4 days, so 8 hours it becomes. So on an average, you can assume that it goes from 4 to 5 months.
Okay, got it. Okay, thanks, Austin. Yep.
Okay. Any other question?
What are the type of training material you are going to provide?
So training material, one thing is whatever session that we are going to have with all the, I mean, every session you will have the recording available in the LMS. And apart from that, you will get, PDFs and like as I told you, we're going to do mostly based on the case studies. So whatever data is there, whatever codes we'll write during the class, so all these things will be provided. And plus some aspects of theoretical aspects also we keep providing. Because see, as I told you, it's not theory. As I told you from the beginning, I'm telling you, it's more of practically implementable thing. So in the class, whatever data we are going to use, all the data will be provided. Whatever codes we are going to use, we are going to provide that. And whatever theoretical, as like in the slides and everything, theoretical aspects of it is also going to be provided, apart from the video that you will have access to.
Okay, so that means that the LMS video will be available for me, yeah, as long as I need it.
Yeah, LMS video will be available to you as long as you have the access to the LMS. Because you won't be able to download it, but it will be available on the LMS for you to access.
Okay, thank you.
Austin, this is Avinash here. Yeah, I have one question like how that platform will be come to us in terms of the practice sessions and all, like how the platform and how the cluster will be being accessible from our side.
Yeah, so,
Is
so
that any?
you will get a separate link to access that LMS. And whatever we are going to cover as part of the, part of this course, we are going to do mostly on our own system. So we'll start like, let's say that we are doing on Python or Anaconda you usually use. So Anaconda will install on the system, and data set I'll keep providing you through that LMS itself, which you can download for you.
Okay. Understand, yeah.
Any other question? Hemendra, do you have any question? Okay, I think so. So this is the part because the way I was trying to prepare this introductory session was I was assuming that some of the participants may be also freshers who are just out of the college. So based on that, I was trying to prepare the different kind of contents here, that how different kind of applications. But most of you are experienced enough, and you would have definitely experienced or at least heard of what are the various things that is happening with machine learning. If you want, I can take you through all these things, like how it is used by in elections. Like in India, it was used very extensively in 2014, 2016 Lok Sabha elections. In US, it started with Barack Obama winning the election. Later on, Donald Trump used it for a lot. So in driverless cars, this is being used. And various different kind of applications are there. Like there are various models in NLP, which is basically mostly towards, like, let's say that if I just give you one example of it, this is a very classic example. So what is happening with this NLP programming is that it is able to comprehend the NLP model which has been built is basically able to comprehend the whole passage and able to come up with the answers like human beings do, almost like human beings. So if you see, this is a research paper which was published. I mean, I was trying to prepare it more from the point of view of freshers who have no clue what is in this thing. But then because most of you are experienced, so I'll not take you and bore you through all these things, but I'll just show you what is happening with it. like let's say that this is just a passage, right? We usually as human beings we read through the passage and we come up with the answers and everything. So this is the question: what was the theme? And the machine is able to answer that one word, one dream. What was the length of the race? 136. So in this particular example, as I'm trying to show this, in this they were able to come up with almost 98% of accuracy. So almost the machine learning models and NLP models are coming to that extent where they are able to comprehend everything. Like if they are able to comprehend such insightful texts and passages, so obviously it means that there is a huge usage of all these technologies. But most of you, as you're experienced of, have heard of it, so I'll not go into all the details and applications of it. But if you still have any questions, that any specific questions, anything that you want to ask from your department or your vertical that you are trying to solve problem on, then I can probably give you insight. Otherwise, let's say like recommendation system. If I give you an example of recommendation system, so what happens in that case is, let's say Amazon.in I put. And I am just saying, let's say some machine learning book. And let's say I'm just clicking on this book, right? So what we see is, along with this book, it will give me some options here that people who have viewed these books have also viewed these books. So what this essentially means is, at the back end, you based on the data, like a lot of people might have, let's say that maybe let's say at 100,000 or maybe 10,000 people have viewed these books. Out of that, let's say 80% people have also viewed some of the combination, like they would have viewed deep learning or deep learning in Python or something. So it is basically from the back end, it is showing us that, okay, these people have viewed this, these people have bought this, you can also buy these things. So this is a classic application of machine learning, which is called recommendation system. A part of it we are going to see as part of course also in association rules. So this is one example. Like that, we can have many examples. Like let's say Google News, news.google. Now, what the news.google does is a lot of from various different media sources, a lot of news comes up. Now, how? So basically, at the back end of this Google algorithm, they have already segregated. Like they have created certain categories based on the information that is available. So there are two things that is happening in this. One thing is, the system is able to read the news and able to figure out from which area it is coming. Is it coming from entertainment? Is it coming from technology? Is it coming from business? So there are two things that is happening. One thing is NLP is there, which is like it is able to read the text, make the comprehension out. I mean, comprehend the text and put it into different kind of clusters. So this is cluster. Like India is one cluster, world is one cluster, local news based on my surfing thing is another cluster, technology another cluster. So there are multiple things. What I'm trying to just say is that different kind of algorithms are working to bring out these things, which is also in a way it is like artificial intelligence, because no one is doing it, but the system itself is learning in that way. Let's say that I just put on technology. So whatever news has come up in the technology, it has come up here. Now from there also the subclusters are made, right? Latest thing, news thing, gadgets, internet, virtual reality, artificial intelligence, and so on and so forth. So this is one example that wherein this is being used. So like this, there can be many examples, like in deep learning is basically being used in self-driving cars. So like this, there are tremendous number of examples, and I started with the coronavirus thing only because that is very simple thing, because there's not much of data available still to make some great predictions from there. But still, data science are using it to solve various problems in a whatever way they can. So these are the applications are immense. It is available in all the, because I have worked with different kind of verticals, and in every vertical I saw that there is some application of it. Something definitely we can do, some improvement definitely we can make out of it. So these are the things, and I was making it, as I told you, I was making it from the point of view of if there are some freshers, some people who have no expertise in, they will be able to comprehend it better. But mostly you are experienced people, so I will not get into all these things. But if you have any specific questions that in your industry, in your whatever you are doing, if you want to solve some problem using data, and if you have questions related to that, you can ask and I can discuss it from there. If anyone has any questions like this. Any questions? Avinash, Pandian, Sisir, anyone? Hemant?
No, Austin.
Okay.
Yeah, I got what I am looking for. Just I want the course content and what are all the tools you are going to teach. And
Yeah, so
yeah, I'm good with this session.
okay, okay. So that is why I didn't want to take you through all the theory because these are all theoretical and most of you would be knowing it. So there's no point wasting anyone's of time. But generally, I'll just take you through some more, two more things here, and then we'll wrap it up. So, like generally, because you are shifting and with some experience, so mostly for you it will be like different kind of role altogether. However, I'll just show you that how generally the roles are for because data science is little vague term, like uh, whatever someone does with data, they start to call themselves data scientists or whatever, like machine learning. But the thing is, there are different kind of roles, like from where you are starting, but mostly from the experience that you have told me. You're, I would expect that you're going to lead the team or something like that kind of experience. You just wanted to have the exposure that where it can be used, and from there you just want to see that how you can guide people or something, or maybe I don't know. Maybe some of you would be wanting to start right from the beginning. So there are different kind of things that can happen with a machine learning. Like data scientist is one different aspect of it. Data analyst, so data scientist is whatever we are talking about is data scientist, wherein they are trying to do the predictive, prescriptive kind of thing. Data analyst is more associated with just data manipulation, pulling the data, making sense of the available data, and so on. Data engineer is more towards creating the data repositories, data warehouses, making the data available so that data scientists can use them. And business intelligence is more towards visualization. So these are different kind of roles, and from where you are starting, you can have different kind of things which different kind of objectives with whatever you have come up to. But this particular course will more focus on data scientist aspect of it, where we are trying to build models, and from that model we try to describe some solutions for future. So this is what this course is going to be primarily aimed at. We'll definitely touch upon all these things because data scientist needs to know something about all these things. But primarily this is what it is going to be, which is machine learning aspect of it.
Uh, Austin, one question from my side. Avinash here.
Yeah.
I always try to look on this data sciences courses, but I never understand one thing that is a very basic one. While doing a data science, we have two options. Like the one is either we can go with the model based approach or we can go with the algorithm based approach. Which one uh, you should advise to do with a 10 years of experience, with having not much knowledge of Java and Scala, but a very good knowledge of Python side?
Okay, so if you don't have, let's say that you don't have experience of Java and Scala, and but you have experience. So I think what you should go for is, see, model and machine learning are not two different things. That is a part of the same thing. What happens is there are two kind of thing which becomes two different kind of routes. Like let's say one thing is data warehouse kind of thing where you are basically managing the data in a way. Like Hadoop side of thing is Spark side of thing. So that is one aspect of it. Another aspect is building the model or building the machine learning thing. So for you, this thing is fine. Like if you have experience with Python, I think data science is what you should be going for, which is about machine learnings and model building, predicting these kind of things. This is what you should be looking for.
But I have seen a client who are very good on the financial side. They always hire a very good algorithm writer. You can say the PhD holders or maybe the math scientist person to write the algorithm, not like the developer or maybe architect like us.
Yes. So as I told you in the beginning itself, right? It is data science is not something that there are a couple of things around it, right? One thing is statistics is a very important parameter here, right?
Mm-hmm.
As I told you in the beginning, see, if you know maths very well, let's say you don't have any programming background, but you know maths and statistics very well, because all these algorithms have a basis of mathematics, right? And specifically in the finance sector, as you have talked about, particularly in, let's say that in trading kind of spaces, algorithmic trading, they are doing a lot. So for them, it becomes very minutest of detail in that area. Very sophisticated statistical skills becomes very important in that in those kind of scenarios. We are not going to focus this course towards statistics, right? because that becomes, you can do your bachelor's or master's and probably PhDs also in those areas, and then you can, because I have taught people who have done PhDs in statistics, but they never had any kind of programming experience at all. So what they wanted to do is, because they had the knowledge, like let's say that simple thing, one thing is linear regression, right, wherein you are trying to figure out the price of some product.
Yeah.
They can use that. Now, they know linear regression very well, because linear regression is a mathematical and statistical concept. They know it very well. But when you are delving with a huge quantity of data, then that you cannot handle manually, or with the tools generally which they learned, like whatever MATLAB or something, whichever they learned as part of their curriculum, is not sufficient to handle this kind of thing. So what they come back is they try to learn Python and implement those techniques, whatever they have learned, like regression, classification, like let's say random forest. Now they are trying to implement it using Python. So those kind of people also come and take classes and learn Python, so that they are able to integrate both of them. You're getting my point? And that is why all these people, like statistical people or mathematics people, are hired specifically in the finance industries and so on.
Okay. And my last question is from the curriculum which you have just shown to us. Is that curriculum is also going to teach us about something cloud?
No, cloud is not part of this. Cloud is not part of this.
Because all the APIs because in my bank, all the APIs which they are using currently is from the Google Cloud or Azure Cloud from side. Yeah. So is that any difference when the APIs which the cloud side is having, or the tutorial which you are showing here?
No, so I'll tell you, there are two things. Whatever you're talking about, the clouds, right? Whether Azure clouds or Google clouds or whatever, AWS, whichever system you're using, that system is used to store your data. Or let's say not only store your data, but basically you can run your algorithms also on those in the cloud itself, in a way. Right?
Yeah.
So what you can do is, see, there are two things. Let's say that you are using Azure cloud, or let's say you are using Google cloud itself. So you can run all these models because you have data already stored in there. That is what I assume, because you are using clouds, right?
Yes. Yeah.
So your data is there. What you can do is, whatever you are learning, you can directly connect it through your API and start learning using these models on that data set itself. So that is what this will facilitate. This will not facilitate how do you manipulate data on those clouds, because they will have different kind of, like, let's say this is this is cloud agnostic, or let's say that this is data management server agnostic in a way. Whether you are using it on any other server, right? You're using it on the local machine or you're using it on some cloud. You can use these techniques anywhere. So this is agnostic to where the data is kept.
Okay.
Any other questions? Hello?
No, still nothing from my side.
Okay. So I think then this is about it, because there's no point. I have the slide, but then that slide contains just the theoretical aspects of it. So I don't want to go in there and just more waste your time also. That is why I just want to have it a little more interactive. If you have questions, you can ask. Otherwise, the course content we have seen, that is a more important parameter here, because for you, this is what you would have wanted to know, that what is going to be we're going to cover as part of this. Okay, so if there are no questions, you can we can just log off then. And it is very nice to have all of you on this Sunday evening in India and wherever you are.
Okay, fine.
Yeah,
Thanks.
thank you, Austin. Thank you.
Thank you.
Yeah.
And stay safe, because the situation still is very critical in wherever we are. So
Yes, yeah. Thank you.
okay, thank you.
Bye.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to like and subscribe to our channel. Also, feel free to ask your questions in the comment section below, and we will reply to them at the earliest.